Okay, so a lot of us go to this webpage. This is going to be the Autodesk Knowledge Network, and we try to find the software that we're looking at. So let's jump to this real quick. I'm going to pull this up live. So this is where we'd go. A lot of times we're going to go to our software vendor to look and see what they recommend. And this is one of the reasons I think I wanted to teach this class is really, you can't really rely on your software vendors. So Revit 2021 just came out. So if I was to go to the Autodesk Knowledge Network, click on Revit, go down here to System Requirements for Autodesk Revit 2021, select that, and let's just go look at what they recommend for a large complex model. The first thing I do when I jump in here, when I'm trying to spec out a system, I would look for my CPU type. So the first thing I see in here is they recommend a single or multi-core Intel Xeon processor. The challenge there is that every Intel Xeon processor is either single or multi-core. So right here, we're off to a bad start. They have specified any Intel Xeon processor would work. Okay, so they didn't really get very specific. The next thing they're recommending is either a Xeon or an i-series processor. Well, Intel only makes two processors. It's either a Xeon processor or it's an i-series processor. So what they've specified in this first segment is that it's any Intel processor. The next thing they say in here is an AMD equivalent. So in short, what they've said for Autodesk Revit is any Intel processor or any AMD processor. I'm not picking on Autodesk here. What I'm kind of highlighting here is that if you've been going to your software vendor to look for what you should buy, you probably don't have a great system. And it's not their fault. Software vendors don't always know what hardware would run their software well, but I want to kind of go through here and point out a little bit of this. So any processor right now, we haven't really drilled down on what processor is good for Revit. Next up is Autodesk is saying that Revit uses multiple cores for many tasks. I would somewhat disagree. I would say Autodesk Revit uses a few cores for several tasks. Additionally, we jump down in here and it says for large complex models, 32 gigabytes of RAM is sufficient. I would disagree. I would say for about 85% of people, 32 gigabytes of RAM is more than enough. I want to stop right here and I want to kind of show everybody how to figure out how much RAM you need for the softwares you're using. So I'm going to pull this up real quick. If you give me 1 second. If you've ever wondered how much RAM you need for your system, the best thing to do is to come down here, right click on the Windows icon, go up here to Task Manager. Okay, once you get to Task Manager, typically it'll be on Processes if you've ever seen this screen. I want you to go up here and click on Performance, select Memory. Okay, let's make this big real quick. And if you come down here, in use, you'll see 6.8 on my computer. I have 32 gigabytes of RAM in here, and I have 24 gigabytes available. What we recommend to all our clients, if you ever want to know how much RAM you need in your system, is turn your computer on, open up all the programs that you're going to ever be running when you're typically working. It might be 2 instances of Revit, it might be Navisworks, you might have Revisto open, you might be running Inkscape. Open up everything that you typically run and go down in here and look and see how much you have in use. Okay. If you're sitting in here and your in use is around 27 or 28 gigabytes of RAM, and that's about capping out, you're safe with 32. It might be recommended to jump to 64. If you're sitting in here and you have 30 gigabytes of RAM and you only have 32 in your system, I would definitely recommend you going to 64. If you're only using 16 gigabytes of RAM when you have every program open, you're more than safe at 32 gigabytes of RAM. But this is definitely where I would tell people this is the best way to go figure out how much RAM you actually need. Once again, you right click on your Windows icon, go to Task Manager, select Performance, click on Memory, and then come down here and see how much you're actually using when you have all the programs you typically use open. This is the best way to figure that out. Okay. One of the reasons that I don't want to kind of harp on this is that software vendors really don't give you a good insight into this, is they don't really spec it out very well. I'm going to go back real quick and do one more software recommendation. And this kind of irks me a little bit, is when we go look at like an Inventor. when we look at Inventor, this is a really dated recommendation. I don't want to pick on them too much, but I noticed this when I was prepping for this coursework. If I go back to Autodesk Inventor 2021, or excuse me, 2020, they have the same recommendation as they do for 2021. And if I go back to Inventor 2019, they have the same recommendation as they do. So they've kind of copied this over. And this is really why I'm not picking on them. One of the things that I'm really kind of trying to drive home here is that it's really best for you to actually kind of pick out what you need, and you need to know this stuff. So this is the why. This is the why you need to kind of know what you need in your system, is because you can't leave it up to chance. If any one of you have ever had, an IT manager go out and look, they probably looked to this Autodesk Knowledge Network and they probably didn't find the best information, which is why a lot of people don't have the right system out there. So let's just jump on into some of this. Next up, this is a point of contention I had. A lot of people have called in and said that laptops are just as powerful as desktops. There was this misconception a couple years ago where everyone said mobile is just as powerful as a desktop. I'm just here to put it out there. We have a Striker 2 desktop, and this is the only time I'm going to talk about our products. Our Striker 2 desktop and our Striker mobile workstation, they have the same desktop processor. They have the same graphics card. They have the same RAM, and practically all the same components. Our Striker desktop, due to our ability to cool it, is 35% faster than our mobile workstation. So what I wanted to harp on with people is, if you're sitting at your desk 65% of the time and you need mobile 35% of the time, the desktop is definitely the best option for you. And then getting a thin laptop or mobile client for the rest of it, 35% increase in productivity is huge for people. I think a lot of times we get people calling us and they say, well, we just need laptops. And then the next thing out of their mouth is, well, what's the best dock for us? Because we need 3 monitors and all this other stuff. I think a lot of times you have to kind of sit back and say, do I really need a laptop, or can I get by with a desktop? 35% greater output is a big difference. And I think just a misconception that laptops are just as powerful as desktops. I just want to kind of clear the air. Desktops are way more powerful than laptops. Next up, I want people to think about cooling. I know this is something that not a lot of people think about, but when you're designing a desktop system, you have to think about cooling. For the most part, a desktop computer turns into an oven, okay? Everything inside of this computer is just heating up. And if you don't engineer it perfectly, it does turn into an oven. So the system on the left, one of the things that we've done engineering our systems is to kind of juggle the airflow. So we're pulling air on the left, we're pulling air up into the case and then out of the case to kind of keep that airflow going. System on the right, you're seeing airflow come in. The problem with this is you get all the hot air and then you're pulling it out through the radiator. So you're actually cooling. What we're seeing right there is the radiator is pulling hot air from in the case to try to cool off the processor. It's just not ideal airflow. This is something that I kind of want to show you. This is with a 9900K processor, and this is different methods of cooling the 9900K, and I'm actually going to show you here in a second. The computer I'm running right now is a 9900K processor, and I'm actually not overclocking it, and I'm going to show you some different things on the hardware monitoring side. A lot of people advertise different speeds and whatnot for the 9900K. These are 3 different cooling methods. And I want you to think about cooling, because regardless of what processor you use, cooling a processor is really what leads to its either performance or lack of performance, okay? There are 2 different ways to cool a processor. There's air cooling, and then there's liquid cooling, and then there's a range of different methods of liquid cooling. Anytime we talk about liquid cooling, we're talking about the size of the radiator, okay? So what we're looking at here is a 240 millimeter radiator. That's the size of the fans, right? So we have 220 millimeter fans, so that's a 240 millimeter liquid cooler. On the bottom here, we have 320 millimeter fans, and that's a 360 millimeter cooler. There's also 120 millimeter cooler. On the top here, we're looking at air-cooled fans. All these pretty much do the same thing. You're pulling water through fans just like your car, and with that cold air, with that ambient air temperature, you're dissipating heat through the air, and then cooling off the processor again. On the right, we're looking at different speeds and what the temperature of the processor gets to be. The 9900K is a really, really good processor, and it has tons of headroom. The thing is it gets hot, okay? I want to go on and pull up, I'm going to pull over right now. This is hardware monitoring of my 9900K in this computer right now. And just to show you, this is a 9900K. I've been running this all day long. So we do see some 5 gigahertz processing, but for the most part, we're seeing 2, 3 to 4 gigahertz. And one thing I want everyone to be mindful of is my net effective. My average clock speed in here is around 2.6 gigahertz. So a lot of people say, well, what gives? The base clock speed for this processor is 3.6. The boost is 5 gigahertz, which we do see, but the average net effective clock speed is around 2.7 gigahertz. This is really due to cooling. On the computer that I'm running right now, it's air cooled. I do not have liquid cooling on the processor that I have right now, which is where you start seeing some of these temperatures. At stock speed, which is a stock computer that I'm running right now, with air cooling, I'm not getting anywhere near to that boost clock that was advertised. The one reason I wanted to bring this up and actually put an air cooler on this system was just to kind of show how big of an impact cooling plays into the performance of a system. Anytime we're talking about overclocking or hitting higher speeds, you got to be focusing on cooling. So anytime you're looking at speccing out your workstation, I would definitely emphasize on how we're going to keep it cool, what kind of case we're putting it in, and how we're going to mitigate temperatures. Okay, selecting a CPU. Now that we've got a case, now that we've got the cooling picked out, I want to talk about processors. Okay, so anytime we talk about processors, we're going to be looking at this juggle up here. There's a scale. You're going to be either having cores or clock speed. The more cores you have, the lower the clock speed. The lower the cores you have, the higher the clock speed. Generally, that's going to be a rule of thumb. Okay, also, typically when you see cores and threads are going to be doubling the size of cores as long as you have hyper-threading. Okay, hyper-threading splits the cores into virtual cores, so that doubles the number of cores you have. It increases the CPU performance by improving the processor efficiency. Okay, not every CPU has hyper-threading. Okay, and we'll get into some of that. Additionally, every CPU is based on its chipset. Will have a different memory type. Xeons are going to have ECC, which is error correcting RAM. They're 9-bit RAM kits. Okay, for the longest time, ECC has been used in scientific communities, same as Xeon processors, due to the fact they didn't have fail rates as often. You're seeing a big shift in that. It's kind of come down to the manufacturing process of processors. And we can get into that a little later on. The quality control in manufacturing of CPU chips has gotten so much better. You're not seeing the disparity between Xeons and iCore processors as much. The quality control has gotten a lot better, so there's not as big a difference. One of the things when you go with ECC RAM is it's very slow. Okay, that's one of the things. You trade off the error correcting with speed. With non-error correcting RAM, which we use in our i9 systems, you can have XMP, which is extreme memory profiles. It's where you go a lot faster. Okay, maximum capacity, which will be dictated by a chipset, it is going to be the maximum capacity you have. I don't think a lot of people in the AEC industry, unless you're doing laser scanning, and we'll get to that, need to worry about the maximum capacity. How do you figure that out? We kind of already went through that by going through the task manager, going to performance, and then going to see how much you have with all your programs open. Memory channels, this is something we want to get into on your chipset. On your motherboard, you're going to have a certain number of, they'll call DIMM slots, okay? A DIMM slot is a RAM chip, okay? So for the Z390 chipset, which we're talking about with the 9900K, you have 4 DIMM slots. A memory channel is 2 RAM sticks working together. So for the Z390 with 4 DIMM slots, you'll have dual channel. Okay. On the X299, where you have 8 DIMM slots, you'll have quad channel. Okay. Just to get those verbs out there. For every processor, you'll have a base clock, a boost clock, and then what we like to call a net effective clock. That net effective clock is going to depend on cooling, clock speed, if you define an overclock, and your use case. Okay. So if I have a processor and I'm putting it under 100% load all day long, I'm going to see a specific net effective clock, even with cooling. Okay. If I'm doing laser scan registration and I'm putting a processor under load all day long, it's going to heat up and slow down. Okay. So that's going to be a lower net effective clock. If I'm using a processor and I'm doing Revit, only using 1 or 2 cores all day long, I'm going to see a higher net effective clock. Okay. Depending upon cooling, if we have optimal cooling all day long, that net effective clock will be higher, which is why cooling is so important. Okay. We want to talk about few core solutions and some of the CPUs that are out there on the market. Okay. Right now, you're going to see all these programs on the right. When we talk about few core solutions, these are the ones that we're specifying. And I'll tell you, I'm not great at PowerPoint, but we will have a PDF sheet. We have marketing that will be distributing this after this. So you will get some of the information in a packet after this. Right now, you're seeing an i7 9th generation 9700K being advertised, as well as the i9 9th generation 9900K. The reason being is these are the 2 fastest processors out there right now. Right now, in the few core solutions, Intel is king of the hill right now. Intel has the fastest processors, which makes for the best experience in few core solutions. When we look at the 9700K versus the 9900K, the reason I recommend the 9900K is due to the fact that you have hyper-threading. Okay. Reason being, and a lot of times when we look at systems, I want y'all to think about the idea of the concept of scarcity. Okay. Every time we look at a computer, we want to talk about resources. A lot of people in our industry, and I'm guessing a lot of people on this right now, are multitaskers. Okay. When you look at 8 cores or 16 threads, that sounds like a lot until you start thinking about it. When you turn your computer on, Windows is probably using 1 or 2 of those threads. Then you open up Outlook or Microsoft Excel. Now you're using another 2 cores. Then you open up Revit, you're probably using 3 cores. Then you open up Navisworks, another 2 cores. You open up Inkscape, now you have another 2 cores. All of a sudden, that 16 thread starts getting whittled away very quickly and you're running out of resources. Okay, so I think you want to kind of balance, even though you're using a few core solutions, once you open 3 or 4 instances of these solutions, you're not just using a few cores. Okay, so that's why we recommend the 9900K. Let's jump into and look at many core solutions and hybrids. So one thing I want to kind of point out, we actually have a client with Clark Construction. They had a user that was using a few core solutions, and they kept calling us and saying, hey, his computer's crashing. We don't understand what's going on. Well, they started talking to us about it, and it turns out he was using few core solutions, but he was also doing some laser scanning at the same time and quite a few others. So we would call him a hybrid user. 50% of the time, 50% of the time, he was doing some ferrocene, and then he was also doing Revit and whatnot. So one of the things that we did, So one of the things we had to do was step him up to a computer that had more resources. We found that in the Threadripper 3960X, which is in our Osprey series. One of the things that we had to juggle, though, is as we jump to the higher core count 24 core processor, we lose some of the clock speed, right? So instead of being at 5 gigahertz, we're now at 4.5 gigahertz. The other thing, though, was that when we started looking at the higher core counts, is do we go to 24 or 32 cores? Once again, we had to look at that core per clock speed. Okay. when we look at the many core solutions, and I think this is something that really matters, is when you're in the VDC world, you know, you are going to be jumping into those few core solutions. Very rarely do we have people that are just doing many core solutions. We do have some laser scanning technicians, and if you're on the line right now, it might make sense to jump to just a 32 core, 64 thread solution. What we often find, though, in our industry are people that are jumping from Navisworks to Revit, but also jump in and do some of these other things like a Fusor or a Synchro. So they do need a high clock speed, but they also need a lot of cores. This is where, when we look at the new Threadripper, when it first came out, and you'll notice over here, there are a couple Threadripper processors. There's a 24 core, a 32 core, and a 64 core. I didn't even put the 64 core on here because we've tested all of them. And the 64 core, you lose so much clock speed that it doesn't make a whole lot of sense for our customers. The 64 core ends up running about 2.4 gigahertz. And if you try to do Revit with a 64 core processor, it's abysmal. And when we ran the 3960X, the 24 core processor, we were able to process 68 scans in under 15 minutes, which means it's amazing at parallel workflows, but it also ran the Revit benchmark in under 100 seconds, which is why we found the 24 core 48 thread 3960 to be an amazing hybrid processor. I want to go in and pull this up over here one more time. This is going to be one of the hardware monitoring tools that we use. Anytime we evaluate a new processor, one of the things that we do, and we do this quite often with a lot of different solutions, we do this with our software vendors. We will come in and we will actually we'll set different recording metrics. So we'll set this for 1/10 of a second. We'll come out, we'll start recording, and we'll actually record this, all the different data in here while we run a program. We record temperature, we'll record thermal throttling if it's throttling, we'll record reading and writing, how often cores are hit, how long they're hit. We can record reading and writing everything that we can get on the processor, everything we can get about our drives, graphics cards through this, and we'll chart it throughout a program. That's how we learn how these programs actually hit our hardware. And then we can go back and look and see how efficient a 24 core was versus a 32 core processor. So this is where we kind of start learning whether we need a 32 core or 24 core processor. All right, let's get into some drives. This is probably going to be the biggest impact for most of y'all when we're looking to upgrade. So on the right side, you're going to see all the different drives that are available right now. I think one of the things that kind of irks me, and probably my biggest pet peeve, is there are a lot of different classes I've seen that are talking about what you should do in the AEC, and everybody says upgrade to a solid state drive. It's a big pet peeve of mine because solid state drives are old. Okay, solid state drives came out in 1991, and they've been around for forever. Okay, solid state drives are on the SATA interface, which is maxes out at 6 gigabits per second, 6 gigabits per second, excuse me. Additionally, a lot of people say, you know, you can get cheap storage, which is a hard disk drive, okay? Right now, if you have dual gigabit LAN, which is what most people have on their workstation, you can actually get faster internet storage than you can from a spinning solid hard drive. So that's a big pet peeve of mine. Next thing up is memory and drives are going down in cost. Right now, the fastest thing you can get to put in your computer is going to be an NVMe drive. They're about the size of a bubblegum stick. You can see it over here on the right, that 970 Pro drive. I mean, you can get, I think, a 250 gigabyte version for close to $120. And it is the best upgrade you could possibly have in your computer. But let's go through this real quick. Historically, SATA has been the interface that you've been able to do. It goes through your chipset, and your chipset controls how everything works on your computer. It dictates how your processor interacts with everything on your motherboard, okay? The only caveat to that is the PCIe connection, okay? PCIe came out, and that is direct. Anything that's connected to your computer via PCIe is direct to your processor, okay? This is very advantageous. This is how graphics cards connect to your computer. This is how drives, modern day drives like the Intel Optane drive. This is how your NVMe drives connect to your processor. This is what removes the limitations of the chipset. This is why our new drives, this is why graphics cards are so fast right now, is because they do not go through the chipset. So right now we're on revision 4.0 if you're using AMD, and Intel we're on 3.0 right now. PCIe 5.0 has already come out. And if you look at this bottom chart down here, I think the one thing that I would point out right now is most people are getting excited about 4.0, but as if you look at this chart down here, 3.0 x16 bandwidth is 32 gigabytes per second. At BIMBOX, we have some of the fastest RAID drives available, and we can't even tap out a 32 gigabyte per second lane with the fastest drives we have right now. On the PCIe 4.0, 64 gigabytes per second, I don't think there's anything that can go anywhere near that fast or requires that much bandwidth. So while it's exciting, we're not anywhere near that as far as devices being able to go that fast. So it's cool, but we're not there yet. As far as performance, and this is really where we kind of want to clear the air. I know it can be somewhat confusing. A lot of times people advertise these crazy speeds on drives. You're going to have capacity, which is going to be volume of storage. You're going to have speed, which is going to be in sequential reads and writes, which is what you'll see a lot of people advertise. A lot of times you'll see 3,500 megabytes per second or 3,000 megabytes per second. That's really going to be under ideal conditions. That's not typically how a computer works. When you're thinking about how a computer works, it's going to kind of be random reads and writes, right? If you're saving files, it's not always under ideal conditions. You might save a Revit file that's 40 megabytes. You might open a Word doc that's 2 megabytes. We don't always get to ideally have that happen. So one of the things we want to look at is latency and IOPS. Latency is going to be how long it takes the drive to find a specific file, okay? To find the file it's looking for. So you want the lowest latency possible. IOPS is important, and that is a measure of how many input outputs a drive can do per second. And when you think about that, it's different than reading and writing. Reading and writing is how many megabytes per second. IOPS doesn't care the size of the file, right? It's just looking at how many files can read and write, because you might be reading and writing a 40 megabyte file, a 1 gigabyte file. IOPS just cares how many files are being written, how many transactions are happening per second, which is more true to life, right? We're working with files with different file sizes. So if you have a drive with a high IOPS and low latency, you have a much better performance. Okay, now this is one of my favorite things to talk about. And if you're not familiar with RAID, this is going to be interesting. Okay, RAID is a redundant array of independent disks, a redundant array of inexpensive disks, which is what it started out as, or as BIMBOX trades it, a rapid array of independent disks, okay? So there are a couple different things you can do with RAID, and I'm gonna specify 3 today that I think are important. You're probably gonna see about 7 different forms. These are different ways to configure drives to either get performance, redundancy, or performance and redundancy. So when you're setting up your computer, there are different ways to join drives to get performance, okay? A striped drive would be if you had 2 disk drives. So if I have 2 970 Pros and I want to make them go really fast, I can set them up in a RAID 0. So if I have 2 500 gigabyte drives, I could put them in a RAID 0. They would be one drive representing 1 terabyte. They would be twice as fast as they were independently. The only issue is if one drive fails, I lose all my information. Okay, that is a RAID 0. Twice as fast as a single drive, twice the capacity, but if one of them fails, I lose all my information. Okay. A RAID 1, which your IT manager probably loves, and I would say this right now, anyone that's worried about losing information or a file missing or having a down day of data, a RAID 1 is really, really safe. With a RAID 1, you have 2 drives. They mirror each other. If one drive fails, the other drive is there, backed up all the data, okay? So if you have a 500 gigabyte boot drive, C drive, and you have a RAID 1, there's always another drive mirroring that drive, okay? So if one drive fails, the other drive is there to continue working. A RAID 1 plus 0 or 0 plus 1 is the best of both worlds, right? So you have 4 drives, 2 RAID 0s, and they're mirroring each other. So if one drive fails, you're still having RAID. You get the best of both worlds, right? You get the speed and the redundancy. A RAID 0 can have any number of drives. A RAID 1 has to be an even number of drives. And a RAID 1 plus 0 has to be even number of drives as well. Okay? If you have any questions on this, RAID is very interesting for our people that are trying to do large data processing. What we'll do is we'll tell them to set up a RAID 0 for their processing and as a scratch drive. Once the data is processed, save it over to a RAID 1 type drive for archiving. So there's different uses for different RAIDs. And if you have any other questions, please definitely ask me in this. You can use them for your advantage. And there are definitely some cool ways to take advantage of this for your workflow. Okay, GPUs. This is an interesting topic. Okay, so GPUs for our industry have been making a lot of changes recently. Historically, you've had 2 different types of cards. You've had a Quadro card and you've had a GeForce card, consumer versus a professional. There have been a lot of things kind of changing recently in this market, and I kind of want to touch on that. It's very similar to a CPU. Okay, so the consumer cards have typically been less for processing and more for high clock speed, higher refresh rate for video games, right? Streaming really, really fast images, less long-term processing. So you've had a higher clock speed, lower core count, higher refresh rate, and lower RAM capacity would be a GeForce card. The professional Quadro card is a lower clock speed, higher core count, lower refresh rate, higher RAM capacity, okay? So you kind of trade off processing for clock speed with a GeForce card. There's been a really, really big shift recently, and this has been in the past, I'd say 4 or 5 years. NVIDIA has kind of opened up the world of Quadro drivers, which they typically had locked. GeForce cards and Quadro cards had been physical replicas, and NVIDIA had locked a lot of functionality out of the GeForce cards by drivers, right? So recently, they have released what's called the studio drivers, unlocking a lot of that locked Quadro functionality to the GeForce cards. And a lot of people kind of said, well, why did they do that? And the answer is artificial intelligence and machine learning has really taken over the industry. And Quadro cards and some of their higher end Tesla cards are ideal for AI and machine learning. So NVIDIA has found this whole new market that is willing, that's optimized to run their Quadro cards. So you're seeing that kind of higher end Quadro cards start to become more of the AI and machine learning marketplace. If you look down here on the bottom right, the 24-bit and 30-bit, that 30-bit color was locked completely out of the GeForce cards. With the GeForce cards, you could not get 30-bit color, which was up to 1 billion shades. And if you look, that's really one of the reasons that artists and media and entertainment people had to buy a Quadro card, because if you did not have a Quadro card, you couldn't get 30-bit color. So you're really limited. Right now, with the GeForce cards and even the Quadro cards, you can download the studio driver, which is made for artists, Autodesk support, Adobe support, and it's focused directly on creators, okay? You can also get this, AI and machine learning drivers for Quadro cards and GeForce cards. So right now, it seems that NVIDIA has kind of made this new creator, studio, artist driver series, And it's not so defined by Quadro GeForce as it is use case. If you're a creator, you download the studio drivers. If you're doing more AI machine learning, there's a different driver set for you. So there's been kind of a complete change in the industry, which is very interesting. I do have to say that it's brought around a lot of functionality for us in our industry. We're no longer forced to have to buy the Quadro cards. I would just go on and put it out here. I'd say if you're in our industry and you're looking for a good graphics card, if you're not doing virtual reality, a 2060 Super, 2070 Super is a fantastic card for you. If you're doing AutoCAD and Revit, those are really, really solid cards. I'd say if you're doing virtual reality, Lumion, you probably 2080 Super is going to be good for you. 2080 Ti obviously is overkill for most people, but budget accommodating, it's future-proofing yourself. Okay. All right, I'm going to go through motherboard real quick. Most people don't really ever look at this, but it is the chassis that holds everything together. Excuse me. So chipset is going to be unique to this, and it is going to define how everything communicates with the processor. Okay. First of all, it's going to define how many PCIe lanes are available and how they're all tied together. Okay. This motherboard is a Maximus Xi. It is a Z390. The Z390 chipset has 24 PCIe lanes. Okay. That's 8 from the chipset and 16 from the CPU. Okay. So the CPU chipset, CPU PCIe lanes are highlighted in green. Okay. The 8 from the chipset are highlighted in that pink, the neon pink. So those are divided up between the rear IO, the SATA drives over here on the right, SATA ports, and then the M.2 SATA port right down here on the bottom. This can be extremely challenging. When you start looking at what you have on here, when I talk about scarcity, you see this, you have a couple X16 PCIe slots right down here, this expansion slot 1, 2, and 3. And a lot of people look at this and they start adding things, right? So if you add a graphics card here, you add one here, everyone says, well, we have X16 lanes. It's not the case. And I kind of want to bring this up. You put an M.2 drive here, that's X4. You add a graphics card here, that's X16. Well, we just said we only have 16 lanes, right? So it doesn't work like that. If you put one graphics card in, it gets all X16 lanes. If you put a card in here and a card in here, both get 8. If you populate all 3 of these, one gets 8, one gets 4, and the other gets 4. So when you start stacking up your motherboard, you got to think about how you're going to use it, right? What are you going to give priority to? Does the graphics card get priority? If you put in an Optane drive, do you give it priority? I know we talk about this often. There are other things that we have to talk about. High-end motherboards come with 10 gigabit LAN. That 10 gigabit LAN would be going through the chipset and would not be pulling from your 16 lanes to your CPU on a high-end motherboard. If you didn't get a high-end motherboard and you had to get a 10 gig add-in card, that would be pulling from your 16 lanes to your CPU. So you'd be losing those lanes potentially from another add-in card you want to get. I hope that makes sense. I'm going to go on and pull up real quick before we jump out of here. Real quick to talk about our motherboard. Let me pull this over here for you real quick. This is the motherboard we were just looking at. And when you start getting into the minutia of it, this is where you start finding out, you know, the motherboard. Let me go back real quick. Overview. So when we start looking at RAM compatibility and all the different things, one second. Oh. When we look at RAM compatibility and all the different sockets, there are tons of different things that come into play. If you use this M.2, this becomes PCIe. If you use 2 of these ports, this becomes a single lane. Motherboards are very specific, and I want to point out real quick, if you come to a motherboard, always look at the specifications. As you come through here, this is interesting. This is where it starts to show. You have one X16. If you use 2 of those slots, it's dual X8. If you use 3, it's X8, X4, X4. And it starts to divvy these up. This is where you start looking at your M2 sockets. One of them can either be SATA and PCIe, and one is just PCIe. So you have to figure out what M2 slot you're going to populate. If Optane memory is ready, which slot you can put that in, what kind of wireless you have. And then there's always these asterisks at the bottom of a motherboard panel. This is really where they get you. So there's a lot that goes into selection. And I'm going to open it up for questions now. I know I've been long-winded, but if anyone has any questions, I'm going to open it up and try to answer anything you have. NVMe drives, are they only for laptops? No, you can get NVMe drives for desktops and laptops. You need to make sure that you have an M.2 slot for your laptop or desktop. There also are M.2s, NVMe drives that are not M.2 form factor. You can get them in a 2.5 inch form factor. So if you have any questions specifically, if you shoot me an email, my email is buck@bimboxusa.com. Shoot me your make and model of your laptop, and I'll try to help you find a compatible M.2 or NVMe drive for you. Advantages of dual processors. So this is a good question. Up to this point, the advantage of dual processors was to get a higher capacity of cores. And you typically had to go with a Xeon. That was the advantage of Xeon processors, was you could get a higher core count. I'll tell you, the reason we haven't gone with dual Xeon processors was for the fact that we didn't really go that direction. When you went with dual processors, you went with lower clock speed. For us, when we at BIMBOX, to achieve higher core count, we went with a Raptor, which was an 18 core that we get overclock. The reason we did that is most of the people in our industry that needed a higher core count also needed a higher clock speed, and they suffered too much when we went with the dual Xeon setup because the clock speed was like 2.2 or 2.3 gigahertz. Our Raptor with the 18 core, we could overclock it to like 4.6 gigahertz. Now with AMD's release of their 64 core processor, we can clock that at 4.0 gigahertz. To put that in perspective, right now, if I wanted to get close to 64 cores on Intel, I would have to buy 2 28-core Xeons, and they're $10,000 a piece. So I'd have 56 cores, 2 Xeons. It would cost me $20,000 to buy 2 Xeons to get close to where AMD is. I wasn't a big fan of AMD. I have to tell you, about 4 years ago at BIMBOX, we tried them out. I didn't have a great experience with them. About 6 months ago, I started working with their R&D team. They sent me over some of their new Threadrippers. And to be honest with you, I've been blown away with them. We just released the Osprey series. They're bulletproof for high core count. AMD is killing it right now. So I don't think you need the dual processors. I think AMD has shown that you can get that high core count without dual processors. I hope that answered your question. Let's go through these. I think I got the dual processors. Rendering in Lumion plus Revit needed added memory cores as well as GPU. Okay, so rendering in Lumion plus Revit. Rendering in Lumion, it's a lot of GPU. I would say if you're rendering in Lumion, I'd get a 2080. I'd definitely beef up the graphics card. I'd go the 2080 or 2080 Ti. You don't need anything more than that. That's pretty much it. As far as Lumion doesn't use a whole lot of your CPU, it's a lot of GPU. So I'd stick with like a 9900K on the CPU and definitely get like a 2080 or a 2080 Super on the GPU, and you're going to be golden on Lumion rendering. As far as No, and that's all you need for Lumion. Lumion's all about your GPU. You want to make sure you have 8 to 11 gigabytes of GRAM, which is 2080 Super, and 2080 Ti. Bang for your buck for the iCore Xeon. We don't use Xeon processors. All we use is iCore, and that's just because we have a higher clock speed and they're really good. Traditionally, Xeons had this aura that they didn't have, they didn't fail. Like I said, our iCore series, they're above and beyond higher clock speeds. They have better RAM compatibility with higher speed RAM, and we don't have an issue with them. The biggest thing with going with the Xeon is you can go the dual socket, but like I said, we have the higher core count with AMD. Right now, we can get a 24 core, 48 thread AMD processor running at 4.4 gigahertz, and Xeon has nothing that can compete with that. We don't run Xeons at BIMBOX. The fact that they're locked and they have low clock speeds just make them unadvantageous for us. I hope that answers that. And just to touch on that, I think one thing that I haven't kind of touched on is why. For a long time, if you went to Autodesk, they would recommend Xeons and Quadro cards. And that was because that was what Intel and NVIDIA told them to recommend. And it's because Autodesk does not recommend hardware. They don't test hardware. They would just do whatever Intel and NVIDIA recommended. Let's see, do you need to uninstall the game-ready drivers on NVIDIA before installing studio drivers, or does it run in parallel? So you can pick which one you want to install, or excuse me, you can pick which one, but you can run them in parallel. What I think the big thing is choosing which one you want to update. So if you are sticking with the studio drivers, you can just choose to update the studio drivers. You don't have to choose to update the game ready drivers, if that makes sense. Game ready drivers have updates every 3 or 4 days. Studio drivers, it's typically every couple weeks. So you're not always having to update. My recommendation would be to go in and do a clean install of the studio drivers and then just update as the studio drivers are. So what you can do is go to the NVIDIA webpage, download the studio drivers, and when you're doing the install, click clean, it's custom install, do a clean install, which will wipe out all drivers, will reinstall the studio drivers, and then just update from there, just the studio drivers. That'd be my recommendation. And also, just want to recommend y'all, my email is buck@bimboxusa.com. If you have any questions outside of this, or you have anything you want to ask me, just shoot me an email. I'm always around and always happy to help. Basic BIMBOX desktop, that would be our Revit workstation, AutoCAD workstation. It's going to be a 9900K. We do what's called the direct ID lid. So we modify our Intel processor. Let me see if I can pull up an image of that real quick. So, one second, images. So if you're still able to see this real quick, one second. Oh shoot, my fault. So what we do is we do a direct eye cooling. We actually take the Intel heatsink off. We mount our cooler directly to the CPU die. We get a 20% reduction in temperature, and we use a 360 millimeter cooler. That's how we can clock our processors to 5.2 gigahertz all day long. We get about a 35% increase in performance over competitors using a similar processor. That's why we get such a good performance in a few core solutions. We do the same thing on our Raptor, which is the 18-core Intel I-Core processor. That's why our Raptor can run 18 cores, 36 threads at 4.6 gigahertz. We're doing the same thing to the AMD processors in our Osprey series. So we have a 24-core, 48-thread AMD processor that is direct-eye cooled, that we can run at 4.3 gigahertz. And when you look at that, that's 24 core, 48 threads. The Xeon processors, it would take 2 Xeons to get to 22 cores, and they'd be running 2.4 gigahertz. So we're literally processing twice as much data as a dual Xeon setup with a single AMD processor. It's the clock speed that really makes the impact. The higher the clock speed, that means you have a good experience in a few core solutions, and you also have all those threads for multi-core solutions. That's really what we focus on. So many people in the AEC industry have to have that high single core solution clock speed, but also need a lot of cores for the other ones that they're using. A lot of people jump into Fuser. A lot of people are doing some post-process rendering with V-Ray. And they need both. You got to have the best of both worlds. Otherwise, you have to have two systems. And that's really what we focus on. But I'll tell you, the typical desktop that we sell is an overclock 9900K with a direct ID lid, 2070 Super, 512 gigabyte 970 Pro, and they're lightning fast. We just created a new BIMBOX benchmark. We'd love for you to go to the webpage, download the benchmark, and check it out. We've posted our scores. And if you want to give it a run, just put your information in, download it, run it, and see how you stack up. All right, I appreciate everybody for joining us. Thank you so much. And once again, you can reach out to me at buck@bimboxusa.com.